Hey guys and gals, welcome. How you doing? How are you doing this fine day? Let's go. Appreciate you hitting that play button again. I love it. You know I love it. Turn that up. You guys are awesome. Every single one of you. Thank you for dropping by and learning and growing. Let's go. I need to get excited too. I really do. Yes. All right, we're going to get right into it, and then we're going to get some work done. We are working on measures of length. Last video where we kind of went over some definitions and such. And then we're going to kind of just work on some different little problems. So yeah, look forward to that. Quickly, home parents that are homeschooling their children. This is additional support for you guys, parents, homeschooling your child or children. Here to help. I am here to help. To let you know, staying focused and on topic as well. Teaching mathematics over here. Pretty much any grade level, I guess. Yeah. It's great to have you guys. So, I'm assuming you parents are gonna have a lot on your plate. I mean, that's what I'm thinking. Obviously, there's a lot of different subjects, so it's great to have you, and the goal is to help your child or children learn and grow in mathematics. Turn it up. Students as well, you're obviously, of course, you're welcome here as well. Maybe you're looking for additional support and help, assistance here on YouTube. That is great. I'm here to help you as well. Again, parents, students, if you're looking for any particular area or subject that you're working on in mathematics, just let me know. Comments below, and I'll do a video specifically designed just for you. I'm gonna do my best to help you guys, gals and parents and students, be successful in mathematics. I am also offering, extra tips and support and advice and just little tips and tricks to help make, doing mathematics easier. With that said, let's get into this. All right, the two most popular systems of measurement, what are they? Well, in the world, right? They are, we went over it briefly on in the definitions, and that is the System International or International System, if we say that in English, the SI system, and then the Imperial system, okay, of measurement. So two systems to learn. Again, I grew up with Imperial, so that was kind of the first system I learned. And then, when I began school as a young lad, elementary or whatever, that's when we were introduced to the metric system. So it's been around a long time. Quick coffee drink, and then we're going to get into this, okay? Oh, yeah. I let my coffee get a little cold, though. Oh, well. Okay, let's see. Up in the north, The system of measurement is called the metric system. Yeah, that's what it's usually called, right? It's either the metric system or the imperial system. That's kind of what we know it as, right? The metric system was first defined in 1824, less than 200 years ago. It's the world's most widely used system of measurement. Okay, well, that's self-opinion. Just because someone says it doesn't mean it's true. Well, you have to kind of get your facts and information, right? Be certain of that, right? Just be certain of it. So I would agree, probably it was introduced, first defined in 1824. But I wouldn't say it was I mean, I guess it's the most widely used, I guess. I don't know. I grew up the imperial first, so. Anyways, to continue on, I guess it doesn't hurt to learn and understand both systems, right? They're really not, either one of them, they're not that difficult to learn. The metric system is pretty much like if you can count by one, you can do the metric system. All you need to know is how to count. Okay. All right, guys, let's be serious. In the metric system, the base unit of measuring lengths is the meter. Symbol M is usually used. A referent is an item used to estimate a measure. I don't use them. I use actual measuring tools. I want to know the exact number. I'm not going to use my pinky. Oh, well, that looks like it's about 1 centimeter. No, I want to measure it. No. Okay, move around the room and find something that has a length of 1 meter. We kind of talked about that. 1 meter, 3 foot 3 3/8. Right, guys and gals? The meter stick is divided into 100 units called centimeters. What is something that has a length of about 1 centimeter? 1 centimeter is, if I was to convert that, just to give you an idea, I'm thinking it's not a ½ inch, but centimeter to inches. So just tenths, hundredths to 100,000ths of an inch. Now, not to get too technical, it's just over 3/8. Okay, just over 3/8 of an inch. 1 centimeter. Okay. How many centimeters in 2 meters? Well, if they say if 1 meter, what the? Not sure what happened there. It's like it skipped. It's weird. Okay, if you see M, that's a meter. Okay, and they're saying a meter stick is divided into 100 units. So there's 100 units. I guess they call it units. Sure. We'll just roll with it. And called centimeters. Okay. So 1 unit equals 1 centimeter. And just like I said, 1 centimeter is, let's use the approximately equal to, it's a little bit higher than 3/8. Okay? It's probably why I could do fractions well, because that's this. I grew up with the imperial system, so fractions don't scare me. Okay, how many centimeters are in 2 meters? Well, you would just double it, right? 100 units. So if there's 100 units, that would be 100 centimeters, right? Just to confirm, centimeters to meters, right? So it says 0.01, but I'm going to reverse that. Meters to centimeters. Yeah, 100 centimeters. Okay, so we can go like that, we can go like that, and we could just say 100 centimeters. Okay? What is something, again, 1 meter is 3 foot, 3 3/8, just to give you an idea, okay? All right. Find your height in centimeters again. I mean, they do measure you in centimeters, I guess, or whatever, but I don't know. I'm old school. I grew up with imperials, so normally when we're talking about our height, our physical height, we usually say feet, inches. Okay? I'm just under 6 feet. Alright, so if you want to, you can measure yourself. I don't know, imagine there might be metric measuring tapes out there. I don't buy metric measuring tapes. Maybe some measuring tapes might have the mix of imperial and metric. There's probably some out there. I don't know. When I was framing carpentry work, I always measured my cuts in feet, inches. So, if you only have imperial measuring tape, you can actually convert it too, right? So the conversion would be here. We know we could go 100, let's see how, 1 meter, yeah, we could go 100 centimeters. And then we can convert this to, that's 3 feet, 12 times 3, right? Because 1 foot is 12 inches. 6 and 3 plus this 3 is 39. And then we just got to bring down the 3/8. Okay, so we can go 39.375. Okay, there's your conversion right there. And left-hand side equals right-hand side. Okay, if you know what I'm talking about. Hopefully you've been following the series, you'll know what I'm talking about. Okay, this will be your measuring tape, and then this will be the unknown. And then you can convert it, right? If you wanted to know how tall you are in centimeters. Okay? Again, this has to be in inches, okay? Inches. Not feet, inches. Measure in inches, okay? Easy peasy lemon squeezy. Let's go. drop the yays just for funsies. Why not? Okay. So let's continue. What else do we have for information? The meter is the base unit of length in the metric system. Yep. Okay. Prefixes relate all other metric units to the meter. Okay, sure, whatever you're saying. The millimeter, centimeter, meter, kilometer are the units commonly used to measure length in the metric system. Yeah, that's true. Okay, millimeter, centimeter, meter, kilometer. Okay, and then I'll give you guys and gals kind of the conversion for it from metric to imperial, or vice versa. Okay. So quickly, I'm just going to get that out of the way. Let's see, kilometer to mile. Yeah, 5/8 of a mile. Okay, 1 kilometer equals, if you want to be accurate, somewhat accurate, it's basically 5/8, and I'll give you an extra significant digit. Okay, 5/8 of a mile. A centimeter, 1 centimeter equals 10 millimeters. Okay. Right, so they're smaller. It takes 10 millimeters to equal 1 centimeter. All right. And then, of course, 1 meter equals 39.375, right? Inches. Okay, I get that right? I hope so. Of course it's right. That's because I did it. It has to be right. Right? Meter to inches. 39.37. 0 they have. Close enough, right? Tenths, hundredths, thousandths. We're 5,000ths. Tenths, hundredths, thousandths. We're 5,000ths of an inch out. Okay? So, and I guess I could have said that, but yeah. Alright? That's still basically 3/8. Okay. Now I haven't measured. Apparently a dime, 10 cents, is a millimeter thick. That's a bit better. Thick. Right, so the profile. Okay. Now, find yourself, I don't know, a measuring tape or a ruler. I'm not going to really draw a ruler. You could just do some random measuring. Like maybe for fun, you can measure one of your house keys and centimeters. Centimeters, maybe, I don't know. It's like I said, it's 3/8, right? I guess I should have wrote that here. 10 mil. It's also millimeters to inches. What? Hang on, hold up. Let's go centimeter. Yeah, that's right. Okay. Yes, it's a centimeter, not millimeter. 0.394. It's a little bit higher than 3/8. Okay, there's the accuracy. I just rounded up. Okay. And then you can convert back and forth, right? Maybe you can measure a paper clip, or I don't know, you can measure anything for fun, right? Get yourself a ruler. Right, you'll see normally 1, 2, 3, 4, one little line longer, 1, 2, 3, 4, and then another line, and then 1, right? And then repeat. And you always measure at the 0, right? If you're measuring something, just count the ticks. I might have, this might be 1 centimeter, okay? For example. You can measure an eraser, you can measure your cell phone, you can measure your desk, but you might have to make ticks on your desk because a ruler is maybe what, a foot long? Something like that. And it'll be fun, right? Just have some fun with it. Do some random measuring. Just for practice. Okay, let's get into some work. Guys and gals, all right, we're getting right into it. Serious mode here. Learning, we're learning. Okay, I would love to have fun, but you can have fun after, guys. Once you do your homework and you get your class done and you do your learning, you can give yourself a pat on your back and be happy about yourself for learning because it's really a good feeling. And then you can have some fun. All right? To multiply by powers of 10, such as 10, 100, 1000, okay? This is the move the decimal thing, right? Again, here we go. We're getting into decimal hopscotch, right? So recall, if you move something, let's see, 1, 2, yeah. Okay, so if you multiply something by 10, remember? Okay, multiplying is to the right. Remember that? And in this case, we have 1 0, so it's only 1 decimal jump. Okay, from here to here, 1 decimal jump. If you're multiplying by 100, it's the same thing. You're still going in the same direction. But in this case, it's 2 decimal jumps. All right, I'm just going to use zeros as kind of an example. And we could go on and on and on. But multiplying by numbers with zeros, like 1 with zeros. That's essentially how numbers work. Numbers are patterns and sequences and there's a lot of repetition and repeating in numbers.
Here's the 2-minute story of how I built a
Okay, that's great for you. Yeah, I learned. I tried to start my own business, but I wasn't shared and nobody cared. I did. I tried to get my own computer business going, but I don't know. I'm not getting into that. Let's just say maybe I wasn't shared enough, probably because my viewpoints weren't the same. Who knows? Okay, 3 jumps. 1, 2, 3. Right? Now we got an alien monster. Alright? It's that easy, guys and gals. You take any random number, it doesn't matter what it is. And a regular whole number, right? The decimal is there. We don't normally write it, right? Because it's inferred. We all know this. It's like common knowledge. Now, maybe you don't know this. That's okay. Again, a lot of my teaching habits over here, I'm trying to teach where I have to assume that whoever is learning and watching is new, okay? And there's nothing wrong with that. Okay, we all have to start somewhere. All right, you don't just go from baby bottle to doing derivatives, okay? It's just not realistic. All right? We all learn from somebody. Lucky for me, I had excellent teachers. My mathematics instructors were awesome. Guess what they did? They just taught mathematics. Isn't that amazing? It's crazy. Because of that, I actually excelled. I was blessed. Truly was. Is. Truly is, was, is. Just quenching my thirst again. Okay, so there we go. So when you're working with numbers that are like the powers of 10, I guess you can call it 10, 100, 1000, it's the same thing, right? We could go on forever doing this, guys and gals. It's the same thing. Okay, we could go up to 1 million, we could go up to 1 billion, it's the same thing. Okay, this time I have 4 zeros. 1, 2, 3, 4. Okay, that's how it works. It's that easy. A decimal is just a position in a series of numbers or digits. That's all it is. Okay, once you grind enough numbers, you'll see the patterns. You'll see the sequences. You'll see it. You will. Okay, so here we go. For example, you have a decimal value. Okay, so let's say you actually measured this with, I don't know, calipers or whatever. Obviously, you're going to be using an instrument that has more accuracy. Okay, and we're multiplying by 100. Okay, there we go. Look at how many zeros there are. 2 zeros. Right, you could do this in your head. Easy. Boom. So we went from here, 1, 2 jumps. Pretty easy, right, guys? That's all you really need to remember. And you could do math. You could do math so quick in your head this way, right? This is pretty simple math, guys, right? All you really need to do is take this set of numbers, multiply it by 1. Okay. And then essentially well, I guess you don't really need to do that step. You're going to end up with the same number because anything multiplied by 1 is going to give you the same set of numbers. The only thing different is the decimal moved because of the zeros. Okay? That's all that really has happened. We could do the long math. We could do the long math, guys. Whoops. Like, I'm not going to, but we could. And you would see. Right? This decimal's here. We're just multiplying. You line up the last 2 digits. That's what you do. Only when you're adding, do you line up the decimals. Okay? That's kind of decimals 101 right here. If you guys want me to do a video series on decimals, I'm glad to do it. I have no problems doing that. Okay? And we'll just grind out a bunch of different problems, and then we could, yeah, it'll be fun. Okay. Let's do some other ones for funsies. 5, 4, 3, 7, 4, 3, 7, 6. Multiplied by 1,000. Okay, so all you really need to do, just write the series of numbers without a decimal. Okay, 5, 4, 3, 7, 6. Okay, just write them all out. The decimal's right here. We have 1, 2, 3 zeros. That means we're doing 3 jumps. 1, 2, 3. Okay. So that should be, whoops. That should be our answer right there. And that it is. You can confirm this on a calculator if you want. Okay. Once you did it on your calculator, you'll be like, wow, this guy is smart. Thank you, thank you, thank you. It really is that easy. I'm trying to make math easy for you guys, okay? Don't let big numbers, like, people get scared and run around with their arms flailing up in the air, screaming like a banshee. You just don't overcomplicate it. It's really not that difficult, guys. Okay? I guess a lot of this, you grind enough numbers in math or in mathematics, you start seeing the patterns and you understand. Okay? This is me showing you how to make it simple. 2 zeros, 2 jumps. The decimal's here, okay? 1, 2. That means we're right there. So I'm just gonna put a decimal right there. Should have gave a little bit more room, but there we go. Boom. Okay. Do a couple more here for fun. Times 10. How's the stream doing? Good, I hope. Okay, good. I didn't check to see if you guys could hear me on the stream. Just got right into it. Hopefully you can. I hope you can. How's the stream doing? Good, I hope. Yeah, awesome. Okay, good. I'm my own mod over here, so sometimes I kind of derp if I don't pay attention. I have to do a lot of different things to make sure everything's good. And I won't lie, I've failed in the past doing videos with I don't know, sometimes even in the settings in OBS, it's like, how does it disable my my microphone when I didn't even go into the settings to change it. Like, how's that stuff even happen? All right? I have things like that happen to me. It's like, I swear to God, it's working. It's all trying to work against me. And I'm just trying to help the world. That's all I'm doing. What am I doing so wrong? What is so wrong with what I'm doing? Okay. One jump. 1 0, 1 jump. We just converted 2.5 centimeters to an inch, basically. It's pretty much an inch right there. 2.5, just to give you an idea. It's actually 25.4, but close enough. I think is it millimeters? 25? Yeah, millimeters. My bad. Yeah, that becomes millimeters. Yeah. That is correct. Okay. And here we go. 19. I think this is going to be it for this, but you guys should have it, right? It's really that easy. Okay, so if you have a number that's just a regular whole number with, if you're going, well, where's the decimal? It's right there, okay? This is exactly the same number as that. Okay? The only thing is this one has a little more accuracy. That's all. Okay? Mathematics 101 stuff right there. Okay, 19. Basically, we're just adding 3 zeros. Really, that's what we're doing. That's another way I teach my kid when we're... Okay, and of course I should go like that to show the extra zero. Right? Just to show the decimal place. But I guess we're not really moving a decimal there, so technically speaking, the answer is probably that, right? Logically, because there was no decimal to move. That's okay. We did move a decimal. We moved it 3 jumps from there to here. Okay, this is how, so when you're working with powers of 10, 1,000 is one of the powers of 10. I just say to my kid, keep this simple. We don't need to do the long math. Just go 19 times 1 gives you 19. Then just bring the zeros over. Every single one of them. Okay? If it was, just to give you guys and gals a heads up, if it was 190 times 1,000, this is what we would have. Still 190. 190 times 1. Just bring the zeros. Just bring them over. No sense overcomplicating it. Still 190 times 1, right? And then all we're doing is just bringing the 3 zeros over. Okay? So take note. There's 4 zeros in this, right? Don't forget this one. We have 4. Okay? How are we doing for time? Not bad. A little more time. Trying to keep the learning to like an hour. Okay, so that's multiplying, all right? So when you're multiplying times 10, for example, we go right. Okay? All right? 1 decimal jump. I'm not going to write 100,000. You get the idea, right?
We pretty much take it all.
Oh. I really have to be quick on them commercials, I'm telling you. Give me a sec. Okay. So what do we do if it's division, right? Well, just think opposite, right? It's kind of like this is something else I like to teach you guys and gals, okay? Kind of the teeter-totter thing. Now this really doesn't have an effect on what we're doing here, but it's kind of like that. So this is an equal sign. So whenever we're doing like ratio proportion, this is kind of my ratio proportion analogy. When we make left-hand side equal right-hand side, it's no different if we're working with a positive number that here, if we move it to the other side of the equal sign, the sign changes, okay? I'll go over into this more, but that's essentially what's happening. So it's the same thing, kind of like multiplying. If we take a number from the left side and go to the other side of the equal sign, you're dividing. Okay? Mathematics is a balancing game, a balancing act. It really is. What you do to one side, you got to do to the other. Once you understand that concept, right? So what's the opposite of multiply? Well, obviously it's divide, right? So if we divide by 10, what happens? We go left. It's just the opposite, okay? Now, without, like, I could go on and show you. If you do it with 100, okay, in this case, it's going to be 1 jump to the left. If we divide by 100, it's going to be 2 jumps. Okay, and so on. Okay. Maybe I'll keep that there just for now. All right. So you should be able to do this without a calculator, guys. Again, the goal is to, help those that actually want to learn mathematics and those that are being homeschooled, okay? If you're being homeschooled, be good to your parents, okay? Understand their decision, and just be good and do your homework, okay? Just be awesome, all right? Just keep being awesome. All right, divide by 100. There. So with that analogy or concept, I don't know, for me, like, once it clicked for me when I was doing algebra, I aced my first algebra exam, 100%. And I'm not lying to you guys about that, okay? It was such a good feeling. But before I did that exam, I was like, wow, I understand this, because doing basic algebra, stuff I've never did when I was younger, because I don't know, not to get into a long story, try not to here, right? But when I was in school and I was like, oh wow, I get this. This is so easy. Then I just started grinding problems. I just went, whoa, man, I get this. And I even understand that this has a power of 1. This has a power of 1. This has a power of 1 as well. Okay, it's just not written in there. Okay, here I'm adding. It's just simple adding. If you just think of these as apples. Okay, you can't change an apple if you're adding them together, right? I'm adding, my friend has 2 apples, I have 2 apples. If we put them together in a pile, we end up with 4 apples. Okay, that's adding. But with multiplying, there's an actual power, right? That's a to the power of 1. So if you understand, when you're multiplying, it's actually the powers are m plus n. Now I don't mean to get you confused here, but this is actually m, and this would be n. So really you're just going m plus n, right? That's simple. Okay? So if this is a power of 1, and this is a power of 1, well, we're adding them together. What's 1 plus 1, right? You can add. I mean, don't be scared of this stuff, guys. It's just a little number over top of a letter with another number in front of it. Okay, this just, all right? Hopefully I get a better way to describe how to work with this stuff, right, without confusing it. That's what I'm trying not to do here. So what we're doing here is we multiply the 2's. 2 times 2 is 4. I should have used a different number. I could have used 3. If this was a 3, then I would have 6, right? And then here, all we do is just add the exponents. 1 plus 1 is 2. So a is to the power of 2. And there we go, right? So as soon as this clicked for me, that's when I went, wow. I probably did 500 algebra problems. I did as many as I could do, as many as I wanted to, because I was like, man, this is kind of fun. I just loved it. I was like, yeah, I love this stuff. It's easy. Like how once you follow the basic mathematical rules, that's all you really need to do, guys. Just follow the little math rules. Be consistent, right? As long as you're consistent with the math rules, you're going to be fine. Okay, I didn't mean to get on that tangent, but a little bit of some kind of forward stuff you can expect in the future from the channel. Okay, working with doing some basic algebra. Okay, I just gave you 2 examples, and it's really, you should be able to do algebra already just based on what I showed you. Really, literally. Okay, so we're dividing by 100. Okay, so that means we're doing we have 2 zeros. It's the same thing. 2 zeros, 2 decimal jumps. So I'm going to just write the number down here, and then figure out, where does the decimal go? 1, 2. There we go. There's our answer. Let's do another one. Five 0 4 7.1 divided by. I don't like writing fractions like this normally, guys. This, technically speaking, is a fraction. I want you guys to understand this. Okay? This is where people mess up in algebra when they're doing BEDMAS stuff. It's when it's written like this. a lot of people, they'll get the answer wrong and they think they're right because simply because they followed the rules of BEDMAS. That's fine. I mean, that's awesome. They followed the rules of BEDMAS, which is great. But what they're forgetting is, now it just depends on the type of problem that you have, right? In the future, I'll show you an example. I'll show you what people do wrong with the example. I have a couple examples. You're gonna have to stay tuned. You're gonna have to stay tuned. Okay, I'm not hiding this behind a paywall either. Okay, doing this all free, freelance, pro bono. I don't know what else you would call it. I'm not making any money doing this. Okay. All right. So my point is, whenever you see a division problem, I recommend you write it out in fraction form. I know a lot of people don't like fractions, and that's why they fail in algebra, because they get scared of fractions. When you're multiplying and dividing fractions, guys, it's really easy. It's so much easier than adding and subtracting fractions. It really is. Okay? But anyways, if you're working on any algebra problems, this is my recommendation in the future. We will get into problems that we'll get to work on. Right? I recommend you write it in fraction form. Forget this. Okay? This can cause problems and mistakes. You'll see it written like this, but it just depends on the algebra problem that's in front of you. This one's a simple one. It's pretty hard. It's pretty difficult. If you mess this up, you messed it up, right? This is a pretty easy problem, which is, my point is, kind of hard to mess it up, right? So we're dividing by 1,000, which means we have 3 decimal jumps. So I'm just going to write it here. Just write the numbers without the decimal. Okay, the decimal's here. We're going 3 jumps. 1, 2, 3. That means our decimal is right here. Okay, guys and gals? Pretty easy, right? Pretty easy. Here's another one. 2.5 divided by 100. Okay? I'm going to have 2 decimal jumps, right? So I'm going to write 2.5. Gee, I didn't really want to write that decimal. I'm just going to write 25. Okay? That's what I wanted to do, actually. And we're going to go 2 decimal jumps. 1, 2. Put the decimal there. What do you do here with the empty space? The empty space, just fill with zeros. Okay? Don't overcomplicate it, right? If it has empty space, put zeros. Okay? That's what you do, right? In a nutshell, keep it simple. Keep it simple, Stanley, okay? That's all you need to do. So, 2 jumps, my bad. 1, 2 jumps. There's our answer. And again, you can check it on a calculator if you want. You could also do the long division. This is divide, right? So here, the denominator's here. Something I had to kind of train my brain to remember. I'm going to add an extra 0 because I kind of want 3 digits, right? So 100 goes into what kind of does, but we really want 3 digits, right? So Why do I want 3 digits? Let me show you. Okay, what times 100 gets us close to 250 without going over? Well, that's 2. Okay, the 2 goes there because we're actually writing 200 here. Okay, that's why I needed the extra 0 because we're working with 3 digits. 3 digits. All right, I gotta deal with a commercial. Just one sec. Okay, now I'm going to subtract. I'm going to drop the 50. At this point, this is kind of how I look at it. Right now, if we were to look at this number, I have a decimal right there. Okay, that's where it is right now. Before I do anything else. And the reason I say that is because I'm going to kind of, I don't know what to call it. I don't really want to call it borrowing a 0. But we need a 0. Okay, again, we need 3 digits. So I'm going to add a 0. Okay, same thing. We're just adding a 0. A place filler, I guess you could call it. So that would be 5, right? 5 times 100 gives us 500. Just showing you the long work, which gives us a remainder of 0. So now, this is why I put the decimal there, because it's like, okay, well, how does it work with the decimal when you're doing long division like this? This is how it works. You look at this number right here, okay? And you say to yourself, how many decimal jumps is it to go from here to here? It's 2. 1, 2 decimal jumps, right? 1, 2. So with that said, all you do is take this decimal, go 2 jumps. 1, 2. There we go. Our decimal's there, and leading 0. You're just putting in place filler zeros. I guess you could call it that. I was trying to think what I could call it. I'm sure there's some weird technical I don't know what I want to call it, over-explained mathematical analogy of it, but really that over-explained mathematical analogy is just some person that thinks they're super smart throwing out a lot of technical jargon to confuse you just so that they can look like they're smart, to confuse you, right? That's what they're doing. They're kind of dumbing you down and making you feel you feel me? Right? That's the worst teacher ever, really, if they're doing that. Okay? They truly are. There's more. I don't want to go on a tangent, but anyways. Okay? You don't need to know all that other unnecessary over-explained wordage, mathematical jargon to confuse you. We just need 2 place filler zeros. There we go. Let's keep it simple, Stanley. 2 place filler zeros. And done. That's how it's done. Okay, I'm going to clean up this. All right. And then we'll do, I don't know, let's do a couple more. Okay, 75 divided by 1,000. Now this is fine if it's just one numerical value being divided by another numerical value. Okay? You don't have to worry so much about putting it in fraction form. I mean, I guess if you're reducing it, right? If that's what we're doing, yes, do it this way, for sure. If you're working with anything that's BEDMAS related, like let's say there was 4 40 here times, I don't know, 6 or something, right? That's when you want to actually write it in, because it's so easy to get. What happens is, okay, this is a plus sign here. That's fine. Okay, that the plus sign is a separator. It's the last thing you do in bed math, anyways. But sometimes you get like where people think that, I don't know. I'll have to show you the problem. I'm just gonna leave it at that. I don't want to over confuse you guys. Okay, we'll get into that. You're just gonna have to watch the videos. I'm doing all these random series videos, and eventually I'll get there, guys. Okay, I'll show you what I mean. You're just gonna have to stay tuned. Okay, I'm not doing any members only stuff. I'm not doing paywall stuff. This is a free class. I'm not asking or begging for anything. Okay? Maybe some money for a bologna sandwich. I have this bologna sandwich kind of joke going on for quite a bunch of my videos, if you've been watching. Alright. 1000 has 3 zeros. I'm just going to write 75. We know the decimal is there. It's the whole number 75, right? On a whole number, that's where the decimal is. Okay, 3 jumps. 1, 2, 3. There's our decimal. Add in our place filler zeros. I like that now. Simple, right? Place filler zeros. So easy. So easy. So we end up with 0.075. Boom. One more. We're kind of technically speaking doing decimals right now. Sometimes I'll do the long multiplication and long division with decimals. If you guys want, I'll do a specific video just on decimals if you like, for fun. Again, this is kind of stuff, like, I'm older now. I'm enjoying doing this at my age. Like, this is good for the brain, right? I'm not going to end up, I don't know. I don't want to go on a tangent, but I don't know. You just got to keep that mind learning. Okay, I'm just gonna say that, right? If you learn this when you're young, you can do your life things, have your fun, enjoy life, and do what you want to do. And then when you get older, you'd be like, yeah, I miss doing math. Yeah, and then here we are. Okay, it's fun, it's great. Beautiful thing. Okay, 3 zeros. 1, 2, 3 zeros. I'm just going to write the number. 4, 8, 7, 2. 3 jumps from here. 1, 2, 3. There's where our decimal goes at our leading zero place filler. This is called a leading zero. Okay, leading. Kind of having fun this video, guys. Okay. All right, boom. So without all this, I'll just go like this. It's weird. That's a 2 there, guys. Okay, boom. Everything's going good. Okay, all right. It's just the program here lags spikes a little bit. That's okay. All right, so there we go, guys. Drop the yays. That is it. That's fun. And that's how easy it is to figure out where a decimal goes when you're multiplying decimal values by the powers of 10. The powers of 10 could be 10, 100, 1,000, 10,000. Okay? Powers of 10. And it's that easy, guys. You could do it in your head. So easy. Like, right? Isn't that so simple? We don't need a calculator because we're part of the 120 and higher IQ club. Okay, guys? Yes, we are. Yeah. Okay, I'll just keep my inside voice in. But nothing negative. Just nothing negative, guys. Not to worry. Like, I was just gonna say it. Educated and I'm on the right, but that's it. I didn't want to get into that, but yeah. Yeah, smart and intelligent we are. Yes, we are. This is for you guys, okay? All right, supporting parents, homeschooling parents, and any students that are looking for additional mathematical support, or maybe you're just learning and new to this, okay? You're all welcome here. I appreciate you being here, learning and growing. You're all awesome, every single one of you. I will see you in the next video. That is it for today. Stay tuned. We're going to do some more. We're going to get into what I call kids help dad until dad calls mom. You're just going to have to stay tuned to check it out. All right, guys, have a good rest of your day, guys and gals. And for now, that's it. I'll see you next video. All right. And peace.